What I want to do in this video is think about exponents in a slightly different way that will be useful for different contexts, and also go through a lot more examples. So in the last video we saw that taking something to an exponent means multiplying that number that many times. So if I had the number -2 and I want to raise it to the third power, this literally means taking three -2's. So this literally means taking three -2's, so -2, -2, and -2, and then multiplying them. So what's this going to be? Well, let's see. -2 times -2 is +4. And then +4 times -2 is -8. So this would be equal to -8. Now, another way of thinking about exponents, instead of saying you're just taking three -2's and multiplying, and this is a completely reasonable way of viewing it, you could also view it as this is the number of times you're going to multiply this number times 1. So you could completely view this as being equal to, so you're going to start with a 1, and you're going to multiply 1 times -2 three times. So this is times -2 times -2 times -2. So clearly these are the same number. Here we just took this and we're just multiplying it by 1. So you're still going to get -8. And this might be a slightly more useful idea to get an intuition for exponents, especially when you start taking things to the 1 or 0 power. So let's think about that a little bit. What is +2 to the, based on this definition, to the 0 power going to be equal to? To the 0 power going to be equal to? Well, we just said, this says how many times are you going to multiply 1 times this number? So this literally says I'm going to take a 1, and I'm going to multiply it by 2 0 times. Well, if I'm going to multiply it by 2 0 times, that means I'm just left with the 1. So 2 to the 0 power is going to be equal to 1. And actually, any non-zero number to the 0 power is 1 by that same rationale. And I'll make another video that will also give a little bit more intuition on there. That might seem very counterintuitive, but it's based on one way of thinking about it, is thinking of an exponent as this. And this will also make sense if we start thinking of what 2 to the first power is. So 2 to the first power. So let's go to this definition we just gave of the exponent. We always start with a 1, and we multiply it by the 2 one time. So 2 is going to be 1. We're only going to multiply it by the 2. I'll use this for multiplication. I'll use the dot. We're only going to multiply it by 2 one time. So 1 times 2, well, that's clearly just going to be equal to 2. And any number to the first power is just going to be equal to that number. And then we can go from there, and you'll, of course, see the pattern. If we say what 2 squared is, 2 squared, well, based on this definition, we start with a 1, and we multiply it by 2 times. So times 2 is going to be equal to 4. And we've seen this before. You go to 2 to the third power. You start with a 1, and then multiply it by 2 three times. So times 2 times 2 times 2. This is going to give us +8. And you probably see a pattern here. Every time we multiply by 2, or every time I should say we raise 2 to a 1 more power, we are multiplying by 2. Notice this. To go from 2 to the 0 to 2 to the 1, we multiplied by 2. I'll use a little X for the multiplication symbol now, the little cross. And then to go from 2 to the first power to 2 to the second power, we multiply by 2. Again. And that makes complete sense, because this is literally telling us how many times are we going to take this number, and how many times are we going to take 1 and multiply it by this number. And so when you go from 2 to the second power to 2 to the third, you're multiplying by 2 one more time. And this is another intuition of why something to the 0 power is equal to 1. If you were to go backwards, if say we didn't know what 2 to the 0 power is, and we were just trying to figure out what would make sense. Well, when we go from 2 to the third power to 2 to the second, we'd be dividing by 2. We're going from 8 to 4. Then we divide by 2 again to go from 2 to the second to 2 to the first. And then maybe it seems like we should just divide by 2 again from going from 2 to the first to 2 to the 0. And that would give us 1.